All right, hello everyone. I did not realize that Screencast-O-Matic only has a 15-minute limit, so I got cut off a little bit. But let's continue where we left off. So there's no outside forces, which means that there's no work. All right, but I did start with more potential energy with initially for car A, and so if there's no work, well then kind of naturally we know we have to have four blocks here, right? So I just kind of need to put this into words that I'm going to have car A ends with more K, right? So again, that's just describing my model. It's what I drew, but why did I draw that? Right? I could say something, because car A starts with more UG, car A ends with more K, right? I could have maybe said for my physics concept, same idea, just said it a little bit differently. Because energy can't be created or destroyed, car A ends with more K. Either of those work, right? But I'm giving a physics concept explanation for why I drew what I did here. Now, notice that we've ended with K here, and we haven't really talked a whole lot about velocity, and that's what the whole claim's about. How the velocities compare? And so, yes, like kinetic energy and velocity are closely related, but they're not the exact same thing. They're just related. So that's what I'm going to get to my concluding statement here. And that's what I introduced earlier in our first video. So using the equation, well, it's definitely going to have velocity because that's what my claim's about. And my only energy that has velocity in it is K, so 1/2 mv squared. So that's going to be what I'm going to be working with here. Right. And let's see, what variable is constant? I always recommend, like here's a template, is just start off with what variable is constant. It makes everything a whole lot easier. So here are my three variables. And it looks like it's the same car, right? Mr. Bozadeh showed the exact same car in his two scenarios. And so if that's the case, out of these variables that are going to be the same, mass is going to be constant. It's going to be the same. I'm also going to kind of draw this and visualize this on the side here, where here's car A, here's car B, and I'm going to draw the mass being boxed in. It's the same. Okay. So if what other variable do we know is either staying the same or increasing or decreasing? Well, we just figured that out from our whole explanation here. If we're talking about car A here, car A ends with more K. So I'm going to draw a much bigger K here, a smaller K here. So if K, or kinetic energy, increases, then, well, let's see. Now, 1/2 is part of my equation, but I really only care about the variables that are going to change. So mass and then velocity. So if my mass is constant, my kinetic energy increases, my velocity would have to go up in order for this equation to work out. Yes, this velocity is squared, but just for simplicity's sake, I'm just going to do this. And you know what, just in case, I can always put a square there if I want. So if going over here, if I have a smaller k, then my velocity would have to be smaller as well. Right? Keep in mind, you do not have to do this ever, but it's just a helpful tool to kind of work with. What it allows us to do is just kind of confirm if we keep mass constant, K increases, then velocity increases as well. And notice how we ended here. Very similar to like our forces explanations, this is essentially what our claim is. Greater velocity for scenario A compared to scenario B. So we've been able to confirm our claim using our physics concepts about energy. So hopefully this was a helpful introduction to kind of see where you're eventually going to go. But today, really the whole goal is just to kind of work on these pieces. So instead of everything at once, just saying like, oh, like no outside forces, so no work, or, car A has a higher height, so I drew more UG. Like just like a statement like that. Right? And where we're going to work with that is page 1 we already did. All right. So page 2, just a very page 3, anything that hasn't been completed yet, and page 4 is what I'd like you guys to practice and complete and submit during class today. All right. Thanks for watching.